topic today is simulation of composites using advanced fiber technologies. And this is the brief outline that I'd like to talk about today. Why do you want to simulate fiber orientations? That is what I'd like to start with, is giving everybody the big picture as to why you want to simulate fiber filled materials. What is the whole point of doing that? And then to quickly dive into what I call as the fiber orientation theory. In other words, the algorithm that is used in simulation technologies to predict fiber orientations. Now, we're going to use a few case studies to supplement this particular concept, the algorithm and how it is applicable in reality, followed by a few other concepts of enhanced fiber technologies, including coupling of fibers, flat fibers, etc. All right, so why do we want to simulate fiber-filled materials? When you talk about composites, particularly for injection molding, you can either have short fiber composites or long fiber composites. And again, within fibers itself, you can have glass fiber or carbon fiber, etc. And of course, from what has been observed, based on the application, different applications warrant different types of fiber fillers or different percentages of fiber fillers. And each tends to have its own applicability. In other words, depending on the type of fiber content you have, that affects the performance of your part. It could be from a stiffness standpoint or from a strength standpoint, withstanding impact standpoint, etc. Now, when you talk about any sort of fiber filler in a material, why or what is the whole purpose, or how does it affect your overall part quality? Now, depending on the kind of fiber you have, depending on, again, a whole lot of different factors, be it your part geometry or your gating, all of these factors impact your orientation of the fiber, the direction in which each of your fiber elements are oriented. Now that in turn will affect how the part is shrinking. It will not be uniform in all directions. Again, depending on the part geometry, it could be shrinking more in your flow direction while not shrinking as much in your cross flow direction, etc.